Have you ever been puzzled by compiler options and how they affect your code? It can be quite confusing, right? If that's you, then you're in the right place. Today, we're diving into the differences between the /volatile ms and /volatile ISO compiler options in Visual C++. I totally get it. Compiler options can feel like a maze, especially when you're trying to understand how they impact your code's behavior. You're not alone in this. Many developers face similar challenges. Here's the specific question we're addressing today. A user asked, what exact code could compile differently with volatile ms and /volatile ISO? This is a great question that gets to the heart of how these options affect code execution. Let's explore this together. So what does each option do? This volatile ms option ensures that the compiler maintains ordering among references to volatile objects, while volatile ISO focuses on a stricter ordering model. This can lead to different behaviors in your code, especially in multi-threaded environments. And stick around. At the end of this video, I'll share a practical example that illustrates these differences in action. You won't want to miss it. To understand the differences between the compiler options, the user should first compile a simple program using the volatile keyword. This will help illustrate how the code behaves under each option. Next, the user should compile this program with this volatile ms option. This option ensures that the compiler maintains the order of operations for volatile variables. After that, the user should compile the same program using the /volatile ISO option. This option follows a different set of rules for ordering, which may lead to different generated code. Now, the user can examine the generated assembly code for both compilations. This will reveal how the ordering of operations differs between the two options. Finally, the user should analyze the differences in the assembly output. This will provide insight into how the volatile ms and /volatile ISO options affect the compiled code. Fun fact, the term volatile in programming comes from the idea of something that can change unexpectedly, just like your plans when your friend cancels at the last minute. Now let's look at the answers provided by other users. Another user suggests considering the undocumented option /volatile metadata. They mention that when this option is enabled, it generates metadata for emulating x86 on ARM. This could potentially impact how volatile ISO affects volatile metadata and x86 code execution on ARM. Here's the practical example I promised. Consider a scenario where two threads are updating a shared counter. The behavior of this counter can vary significantly depending on whether you use volatile ms or /volatile ISO. And there you have it. Understanding the differences between volatile ms and volatile ISO can help you write more reliable code. If you found this video helpful, please subscribe for more insights, and remember to experiment with these options in your own projects.